Now looking at our investigation, first the heart rate during the multi-stage fitness test. Now, as you can see, there's a slight increase between rest and pre-test, showing the anticipatory rise of this. And then between the levels, heart rate increases again and again. So as the intensity of the work increased, so did the heart rate. So as it began at level 2, approximately 85 beats per minute, all the way up to level 8, where it's probably about 140 beats per minute. And that great change shows just how quick the heart rate can change over a short period of time. Also looking at the heart rate, but during the Wingate test, the resting heart rate was about 82 again, maybe a little bit higher. And then pre-test, you can see the heart rate has shot up all the way to probably about 115 actually. And then post-test, the heart rate is about 160 beats per minute. And you can see just between these 20 seconds of maximal exercise, the heart rate has increased by a great amount. Also looking at the blood pressure during the multi-stage fitness test now, you can see that blood pressure didn't really change that much, but you can see the systolic blood pressure slightly increased, but didn't drastically increase, as this wasn't a maximal test, as we only stopped at level 8. But you can see it still increased nonetheless. The diastolic blood pressure, however, that's very constant as well, so that hasn't changed that much. I mean, there was a slight change, but was still quite constant compared to the systolic blood pressure. Looking at the Wingate test now, you can see that the systolic blood pressure increased quite a lot. So from probably about 120 millimoles, millimeters of mercury per litre, all the way up to probably about 140 millimeters of mercury per litre. So you can see a big change there. And then there was a slight change in the diastolic blood pressure, but only a very slight change. You can see the blood pressure on both tests, especially the systolic blood pressure, increasing, and that's due to that link to the heart rate increasing, as blood pressure can be measured as cardiac output multiplied by resistance. So if the heart rate is increasing, that means the cardiac output is increasing, meaning that as the cardiac output is increasing, that means blood pressure will then increase, and specifically systolic blood pressure will increase. In sport, this can change and vary quite a lot. So the diagram to your left here shows the heart rate of a football player over their 90-minute game. So as you can see, it's varying quite a lot, and then you can see there's a big drop here, and this is due to, well, obviously half time. So there's a drop there to show rest before they start off again around here. And you can see there's big fluctuations in heart rate. So this shows different, can show different moments of play. So for here, for example, where it peaks, this could be a short sprint or quite a long sprint actually, like a counter attack, where a player is sprinting from one box to the next, and this will cause an increase in heart rate. But then once that has happened, then the player would likely be walking or slow jogging, which would cause the heart rate to drop once again. And this is repeated throughout the game, which is why there's such a change in heart rate, as the intensity of a football match is constantly changing. A drop down here, for example, this could be when the ball is on the other side of the pitch, so it could be a defender waiting on the halfway line while the ball is in the offensive half, so the attacking half. So for example, a centre back, wouldn't be required to be working that hard at that point and be resting and recovering at that point, which is why there's such a steep drop in the heart rate. Going back to this diagram, on a continuous thing like endurance running, which is shown here, you can see that systolic blood pressure increases but then plateaus, and that is due to its submaximal continuous exercise. And you can also see the diastolic blood pressure is quite constant, so it doesn't change. And that would be in an endurance event like a marathon, for example, where you're working at a slow and low intensity for a long period of time, which is why there's a plateau there. Also, during isometric exercise, there's a large increase in systolic blood pressure and a large increase in diastolic blood pressure, and this could be during weightlifting, for example, when they're holding that bar in that isometric contraction, as they need to hold it for a certain number of seconds for the lift to count in weightlifting. So that would be an isometric contraction, which would cause the blood pressure to increase before they then drop the weight.